Okay, we're going to be evaluating logarithms today. So this is your first experience with logarithms. Let's start off with the definition. The definition of a logarithm with base b looks like this. Log base b of a is equal to x if and only if b to the power x is equal to a. So that means this logarithm equation here is defined as an exponential equation. So that means the two are linked together. Now for this, just like when we were looking at the logarithm graphs, the base has to be greater than 0 and it cannot be equal to 1. Otherwise, it doesn't make any sense. Okay, there are two special logarithms. And those two special logarithms are the common logarithm, which is a logarithm with base 10. So if the base is 10, we just write log of x, like this over here. We don't write the base in there. But it's understood when you see this that that's a base 10. Oops, wrong utensil. So it's understood that this is base 10. All right, the other one is called a natural logarithm, which is a base e. And that one's written as ln of x. So this is read as natural log of x. Now that brings in a special number that we haven't really talked about before, this number called e. This is known as Euler's number. It is an irrational number, a lot like pi, so it's a decimal that goes on forever and ever, never repeats, never terminates. E's approximate value is 2.718, and then it goes on forever, just like pi. No repetitions, and there's no end to it. Alrighty. Okay, so here's a little comic for your enjoyment. I'm moving right along. Okay, now because logarithms and exponentials are linked together, and a logarithm is defined in terms of an exponential, that means anytime you have an exponential equation, you could rewrite it as a logarithm, and anytime you have a logarithmic equation, you could rewrite it as an exponential. So we're going to practice that here. We've got the exponential form on the left, and we're going to write the logarithm form here on the right. So for 2 to the power 3 is equal to 8. We're going to write log. Now the base of the exponential is what we're going to use as the base of the logarithm. So subscripted there, I'm going to write it 2. Then the next thing that we write is known as the argument of the logarithm. That's going to be 8. And that will equal whatever the power is. So a logarithmic expression equals a power. That's something important to remember. Okay, so now for our second one here, 5 squared equals 25. You could pause the video and try that one and see what you do. See what you get, and see if it matches what I have. Again, the base is the base. The logarithmic expression should equal the power. And now we're going to go backwards. So now we've got the logarithmic equation, and we're going to rewrite it as an exponential. So once again, this is log base 3 of 9 equals 2. So we're going to start with the base of the logarithm, raised to the power 2, is equal to 9. All right, for the next one, it says log of 1,000 is equal to 3. So to write it as an exponential, I have to start with the base of the logarithm. And this one, they don't have a base written in there. And that's because this one's a common logarithm. So that means its base is 10. It's understood. So I would say 10 to the power 3 is equal to 1,000. Now, one thing I want to note on these is these equations that we're writing are true statements. end up with something crazy where it says like 3 to the 10th power is 1,000. That's just not true. And you certainly wouldn't have 10 to the 1,000 power equals 3. That would be even crazier. So all of these equations are actually true. Okay, for these last four, we're going to have approximately equal to because they all involve that number e, which in order to use it along with numbers, we have to have an approximation. We can't get the exact value. So e to the fifth is approximately equal to 148.41. So when I rewrite that, I'm going to rewrite it as a logarithm. And because it is a base e, instead of writing log, I'm going to write ln, natural log. And then I'll write the number on the other side of the approximately equal to sign. So 148.41, that'll be the argument. And then that's approximately equal to the power. Now you could try the next one here. Go ahead and pause the video and see what you can do with it. And then come back and see if you got it right. There we go. Okay, now we'll go backwards. So now we're going to have the natural logarithmic equation, and we're going to rewrite it in its exponential form. So natural log of 4 is approximately equal to 1.39. To rewrite it in its exponential form, we'll start with the base, which since it is a natural logarithm, that's a base e, to the power 1.39. Well, I just wouldn't have a good video without some pen lag going on there. Okay, so approximately equal to, and then the argument of the logarithm there, 4. And for that last one, natural log of 1.5 is approximately equal to 0.41. So again, I start with the base e, then I go across the approximately equal to sign to get the power, because the logarithm is always equal to the power, and then approximately equal to 1.5. Alrighty, so now you're going to answer a few questions on the Google form there, and then we'll come back and how to evaluate these things.